Okay, so we will continue solving the thermodynamic relations problem, and the next problem that we are going to do is this one. So, let me write down. We have to show that del V del T at a constant S divided by del V del T at a constant P is 1 by 1 minus gamma, where we know that gamma is Cp by Cv. Now, before I solve that, let us do the right hand side a little bit. So, right hand side is 1 by 1 minus Cp by Cv, giving me 1 by Cv minus Cp by Cv, which is Cv by Cv minus Cp. Now, you see that I can make the equation a little bit simpler by solving the reciprocal of this, which means that if I want to do this del V by del T P by del V by del T S, then I am expecting 1 minus gamma, and 1 minus gamma is nothing but Cv minus Cp by Cv, or 1 minus Cp by Cv. So, that is little bit easier. So, we are going to go that way. So, we are going to solve this one, and then we will prove that the reciprocal of that is 1 by 1 minus gamma. So, let us start doing that. Okay. So, we have to show that this is equal to 1 minus gamma. This is to prove. We have to prove this. Okay. So, we go, let us call that equation 1. Okay, we can always use Jacobian techniques or many other methods that we discussed, but there are also other tricks involved, because you see that when you do Maxwell's relation SPTV, then we can always do dV dt at a P, and then in order to do the S we have to do dt dV at a constant S. That is the tricks, because line will go like this only. So, therefore, we cannot get easily dV dt at S, but we can always take inverse of dt dV at constant S as dV dt at a constant S. Okay. So, we can do that, but let us do a different tricks. So, you know that the V is a function of T and P. So, any one variable is function of other two variables. So, that way we can always express the total differential of a variable with respect to the changes in other two variables. So, dV we can write as del V del T at a constant P dt plus del V del P at a constant T dP. We can write that. So, we are writing the total change. Now, you see I am already having the term del V del T at a constant P. I need del V del T at a constant S. So, therefore, we can differentiate equation 2 by with respect to T at a constant S, and write that as del V del T at a constant S is del V del T at a constant P, and dt by dt will be just 1 plus del V del P at a constant T and del P del T at a constant S. So, we have done that. So, now you see this gives me equation 3. Now, we need this quantity del V del T, we need this quantity del V del T at a constant P by del V del T at a constant S. So, divide both sides by del V del T at a constant S. So, what we get 1 plus no sorry we will get 1 equal to del V del T at a constant P by del V del T at a constant S, because this is what we wanted to get, right. And then this side will get del V del P at a constant T del P del T at a constant S, and we are dividing by this one del V del T at a constant S. So, we get inverse of that del T del V at a constant S. Okay. So, which means that this quantity del V del T at a constant P by del V del T at a constant S is 1 minus del V del P at a constant T del P del T at a constant S and del T del V at a constant S. Okay. So, now we need the help of Jacobian and we can write all that in Jacobian term. So, this will give us V T by del P T. This will give us, second one will give us del P S by del T S. Third one will give us del T S by del V S. Now, you see this T S and this T S will cancel each other and we can write as 1 minus, and remember we have to get C P and C V. So, C P and C V's are del S by del T at a constant P and del S by del T at a constant V. So, you see we are getting similar thing when we use these two. I will just circle them. When we use these two, we are going to get one, and when we use these two, we are going to get the other one. So, now let us write that del V T divided by del V S and del P S divided by del P T, because we know that we are going to get C P by C V, right. So, that is why we chose this route. Now, you see I can interchange both the variables and write T V by S V, and here I can write S P by del T P. Since I change both, then it is positive only. So, 1 minus. So, T V by S V is nothing but, as you can see, it is inverse of C V. So, if we want a little bit one more step, then I can write 1 by del S by del T at a constant V. I hope you understand the step that I did. I just or I can write it in a more this thing. So, I will write del T by del S at a constant V, and I write del S by del T at a constant P. So, you know that this is inverse of del S by del T at a constant V inverse, and del S by del T at a constant P is nothing but, we know it is C P by T. So, 1 minus, and this was C V by T inverse, and this is C P by T. So, what we get here is the 1 minus C P by T divided by C V by T, which is 1 minus C P by C V, which is 1 minus gamma. Now, we started with this quantity, but what we wanted is inverse of that. So, del V by del T at a constant S, therefore, del V by del T at a constant S by del V by del T at a constant P is inverse of 1 minus 1 by minus gamma, or 1 by 1 minus gamma. Okay, so, let us go to the next problem. Next problem that we have to show is C P is equal to this quantity. It is easier to start with the right hand side. So, we will start with the right hand side. First, we write that. So, V I, we have to show that minus T del V del T P del P del T S is equal to C P. That is what we have to show. Okay. So, this is straightforward. So, we will start with the left hand side and we will just expand it in Jacobian form. So, we will write del V P by del T P and we will write del P S by del T S. So, minus T, and as you can see that I can combine these two quantity, these two, and write that as del P S by del T P. I can write del P S by del T P and del V P by del T S. Let me see whether we are right or not. So, del V P del T P del P S del T S, fine. Now, del P S and T P, there is a reason, because you know that we want to do del S by del T at constant pressure, and V P, and that gives us T S. So, that is fine. Let us continue. Minus T. Now, this one we can write as del S P by del T P, but I need a minus sign for that, and this quantity is there is nothing common in that, because we have V p and T s. So, we will have to find out something for that. So, we can say it is V p by del what you can take T p, yeah, we can take T p, yep, we can take T p, and then we can multiply that with T p and it will be T s. Okay. So, now what we get, minus minus plus. So, plus T del S p by del T p, which is going to give us C p already, and let us see what this quantity give us. This is del V by del T at a constant p, and this is del P by del S at a constant T. So, T into del S by del T at a constant P. So, this quantity is C p we know. So, this should cancel each other. So, we can see that again we will write Maxwell's relation S p T V. You see how helpful it is to write always S p T V, because it gives quick thing. So, del V by del T at a constant P means we have to go this way, which means whenever we go this way we just go the parallel way. So, del S by del P at a constant T, but it will be negative. So, minus del S by del P at a constant T, and it is del P by del S at a constant T. So, you can see that we are going to get. So, this is going to cancel each other, as you can see. So, first of all we write minus C p by taking the minus, this minus, and that leaves us with del S by del P at a constant T and del P by del S at a constant T, which will cancel each other because they are just inverse of each other, and we are going to get minus C p. So, minus C p is the answer. So, although it is written plus C p, but it should be minus C p. So, that means it should be plus. Okay. So, now we are going to go to the next problem. We have to show this one. Remember again the notational issues, because Zzymanski used beta as coefficient of thermal expansion alpha. So, we have taken that from Zzymanski. So, actually what we have to show is next problem, which is I x. We have to show that del P by del T at a constant S is minus C p by V alpha T, where alpha is coefficient of thermal expansion. So, let us see that. Okay. So, we will start with that, and so again we are going to use Jacobian. So, del P by del T at a constant S is del P s by del T s. We need C p, remember. So, that means we are going to write that as del P s by del P t, and then you have to multiply with del P t and del T s. So, that is going to give us del S p and del T p, because you know that I can interchange both of them, and the right hand side I can write with a minus sign. I can write that as minus del P t by del S t. Okay. So, this one is going to give us C p by t, or we will just write one more step to show you that it is C p by t. There is a minus sign here, and that is nothing but del P by del S at a constant t. Okay. Now, this is nothing but minus C p by t, and what is this quantity? We need again Maxwell's relation for that, S p T v, and you have to show that which direction is going. So, P s okay. So, you can see that I cannot write P s at a constant t like this, because it is P s at a constant v. So, whenever that kind of situation occurs to you, you see that you have to go this way, S p at a constant t only. You cannot do P s at a constant t. So, it is S p at a constant t. So, you can write del S by del P at a constant t inverse. Okay. So, now what you see that S p at a constant t is nothing but V t at a constant p, negative of that. So, minus del V by del T at a constant p inverse of that, right. minus minus cancels each other. So, Cp by T, and what is del V by del T at a constant P? By definition it is nothing but alpha V inverse. So, we get Cp by T alpha V, because remember alpha is by definition is 1 by V del V by del T at a constant P. So, therefore, del V by del T at a constant P is nothing but alpha V. So, that is also proved. So, I hope that during this exercises you will see that what are the tricks I am using, and when and where things are done, when I am using inverse, when I am using Jacobian, when I am writing it in different forms and adding things. So, if you practice more of such problems, I think it will become easier. Okay, so, now we will go to the next problem. Yeah. So, you can see that there is a minus sign here, but we will first check that whether question is right or not, because let us see that if I have done any mistake or not. So, I was supposed to prove that minus sign, but however, we will just go through that once more and see whether I am correct or not. So, del P by del S, PS and TS, PS and PT, PT, then SPTS and then PTST. This minus sign comes because of interchanging of that one, and then STP, that is fine, then PST, that is also fine, then that minus sign is there, SPT inverse, that is also fine. Now, when I am converting SP to T, SPT, of course, it is SP to T is going down and VT to P is going up. So, there will be a minus sign, minus minus becomes plus. Yeah, so, this is plus. So, therefore, the problem is not correct, it should be plus. Now, we will do the last problem of this thermodynamic relation, because I think we have done enough. So, that now these things become comfortable for you. So, last problem says that del P by del T at a constant S divided by del P by del T at a constant V. We have to prove that to be gamma by gamma minus 1. So, again you see gamma by gamma minus 1 is asked for, but I would like to prove this one, the inverse of this, del P by del T at a constant V, del P by del T at a constant S is gamma minus 1 by gamma, which is 1 minus 1 by gamma, which is 1 minus Cv by Cp. This is what we need to prove. Okay. So, we will use the same tricks that we use for the V problem. So, we can write again P as a function of V and T, just like we did V as a function of P and T, we can do P as a function of V and T, and you can write dP as del P by del V at a constant T dV plus del P by del T dt. Now, we need del P by del T at a constant S. So, divide both sides or integrate both sides, differentiate both sides by T and then at a constant S. So, what you get is that del P by del T at a constant S is del P by del V at a constant T dV by dt at a constant S plus del P by del T at a constant V, dt by dt will not be there anymore. So, now divide both sides by del P by del T at a constant S. We will get 1 equal to del P by del V at a constant T, del V by del T at a constant S, and we are dividing by del P by del T at a constant S. So, which means it is del S by del P at a constant S, plus we are going to get what we are looking for, del P by del T at a constant V by del P by del T at a constant S. Therefore, del P by del T at a constant V, del P by del T at a constant S, which we are trying to prove in this, is 1 minus del P by del V at a constant T, del V by del T at a constant S, del T by del P at a constant S. So, let us call it equation 2. Now, okay, so I can continue that is not a problem, that is equal to 1 minus del Pt del Vt del Vs del Ts del Ts del Ps. You see how easy it becomes. Ts cancel, leaving us 1 minus. Now, we can combine Pt and Ps. So, del Pt del Ps, and we can combine Vs and Vt. So, it becomes Vs and Vt, and you know that we can interchange P on numerator and denominator, giving us del T by del S at a constant P, and this will give us by interchanging del S by del T at a constant V, which gives us 1 minus, this is 1 by Cp by T and this is Cv by T, which is 1 minus Cv by Cp, which is 1 minus 1 by gamma or gamma minus 1 by gamma. So, therefore, what we wanted is inverse of this del P by del T at a constant S by del P by del T at a constant V is gamma by gamma minus 1, and that is proved. Also, another interesting thing to note is that just by changing the constraint, the values are very different. So, they are not equal to 1, right. When you take S as a constraint and V as a constraint, that change in the pressure with respect to temperature is not same when you take the constraints different, because the process itself is different. When you fix the volume, you do not do any work and you hit the system and increase the pressure. When you take S as constant, then you are talking about an adiabatic system and a reversible adiabatic system. Therefore, S is not changing, and you are trying to do some work and then get that. So, therefore, the things are not the same, and therefore, you do that. Okay. So, now we are going to do some other kind of problems, of course, related to this, but also you need a different kind of tricks and different kind of thinking involved. So,